Hello and welcome to Hydraulics 101, a web training series presented by Zemarc Fluid Power. I'm Bernard Hefner, one of the sales engineers at Zemarc, and the person who will be leading you through today's training. Hydraulics 101, Filtration and Preventative Maintenance. In this training, we'll be discussing and explaining all the ways that filtration can play a key role in the lifespan of your power unit or system, and how coordinated preventative maintenance is crucial in keeping your system running optimally. We are going to go over protocols such as preventative maintenance, specification of hydraulic filtration, some tips on how to handle high-pressure systems, and of course, some alternative filtration solutions. Now, before we get started, let me give you some background on Zemarc. We've been in the business since 1976, and Zemarc is a highly respected fluid power distributor and solutions provider that offers a broad range of products and services that support industries like aerospace, transportation, agriculture, general manufacturing, and so many others. We have 4 Zemarc locations throughout California with Parker stores in Los Angeles and Oxnard, and our Fresno and Los Angeles facilities also serve as authorized hydraulic service centers. Zemarc specializes in hydraulic motion control systems, power units, test stands, high-pressure process systems, hose assemblies, and so many others. In addition, Zemarc is a full-line distributor for several industry-leading manufacturers, including Parker Hannifin, Tempesonics, Ingersoll Rand, Delta, Autoclave, Barksdale, and Enerpac. That means we stock hydraulic, pneumatic, hose and fittings, filtration, and process fluid management components. Our team is friendly and available to support your needs whenever they arise. All right, now let's get started with our presentation today. Regular and routine maintenance of equipment is essential to keep it running and prevent any costly, unplanned downtime from equipment failure. A successful maintenance strategy requires planning and scheduling maintenance of equipment before a problem occurs in order to be proactive with your power unit. And speaking of being proactive, Zemarc is top tier when it comes to helping customers understand their systems and issue the best practices to keep it running optimally. We can help identify the effects of poor fluid quality and the potential problems that can arise from it. And we can also help you identify common contaminants that can enter a system and where their general sources can be. But before we get into the exact types of contaminants and how they enter your system, we should first start by identifying the effects of poor fluid quality or contaminated fluid and how it negatively impacts the power unit. Fluid of low quality can run rampant on seals and other vital components in your system, breaking them down and compounding the contaminant. Poor fluid quality in a system can begin what we call a snowball effect of failures if the contaminant introduced is breaking down the components internally. And once a snowball effect starts, the whole system can be compromised from the contaminant. All right. Now that we've gone over some of the effects of poor fluid quality and how contaminant plays a role in the system, we should take some time to address the many different types of contaminants that can affect your system negatively. We'll start with the first one, which is air. Bubbles can get mixed into the fluid easily, your hydraulic fluid easily, and create a huge cavitation risk. And cavitation results in excess heat, reduced lubrication, violent implosions, frictions, and wear. Another contaminant is water, and water enters the system by getting dissolved in the fluid and creating a cavitation risk. Water can actually precipitate out of the fluid, and it can rust internals of the system, blocking pilot lines and causing a potential catastrophe. Another major contaminant is dust or dirt, and this really affects the system because it can abrade sensitive and precise parts like proportional valves, and it can create leaks in the system and abrade seals. Another contaminant is metal, and metal wears down and scratches internal parts of the system, adding more metal particulate to the fluid. And this metal can be ferrous actually, and even build up near magnetic charges internally in the system. When and where there is a contaminant in your system, there are some very common sources that one should evaluate to assure that the contaminant did not stem from said location. Here are some very common spots you'd see for a source of a contaminant. The reservoir breather. Air, water, dust, metal, it really depends on the location of the reservoir breather or the environment that the reservoir is stored in. Let's say if it was in a metal shop or machine woodworking facility or outside in a rainy area or dusty environment, this is when the reservoir can be a major source for contaminant in your system. Another source is the retraction of the cylinder. Dust and debris can get stuck on cylinders when it is extended or actuated, and when the cylinder retracts, some of that debris can enter the fluid through the seals in the cylinder. Another major source of contaminant is not enough cooling, and this, as we identified before, with excess heat being a contaminant. Heat builds up in a hydraulic system as they run, and this excess heat will cause the working fluid to break down prematurely, changing its properties and reducing its usable lifespan while causing damage to other parts and components. So, contaminants this, contaminants that. Let's talk about the key components that will keep those contaminants out while also maintaining your system and assuring its longevity. But before we get into the nitty-gritty of filter choices, here's a quick little list of some of the most common filtration units you'd see in a system and how they function. You have the suction filter, the return filter, pressure filter, your desiccant, and of course, the Parker filter cart. One common way to counteract the contamination of overheating are coolers. Coolers are a very valuable component when seeking to cool the oil in your unit's reservoir at a faster rate than is being done. Two major types of coolers you have are the air over oil and the water over oil. Now, no system can work at peak performance if the fluid is affected with a contaminant. That is why your team and your facility must issue the best practices to assure your system's longevity. And here are some very simple procedures to avoid the future pitfalls of a contaminated system. Do not overheat your system. We spoke earlier about contaminants and the source of contaminants, and overheating your system can play a detrimental role on the longevity of your power unit. Proper sizing of your system, whether that be filtration or correctly understanding the pressure and flow of your system, it's all necessary to be spec'd in order to truly understand how to handle your system. Proper training. The team in the facility that handle the HPU must be trained properly and effectively to issue the best practices when working with your power unit. Filter placement. Whether this be on a return line or downstream of the pump, it's all necessary in the design stage to really ponder where the filter placement if is truly beneficial for your application. So apart from proper practices and maintenance of the system, it is crucial to ponder design considerations for your system as well to assure it runs to your expectations. Couple things here that are worth pondering. Pressure. Things like return filters don't need to handle as much pressure as pressure filters, and that's of course worth noting when designing where you have your filter on. Flow. You must be able to handle the flow of the system with this filtration, and you want to do it with a minimal pressure loss. Fluid type. Is this standard hydraulic oil, Skydraw oil, kerosene, .3 or .4 brake fluid? It all depends. Level of filtration or your rating scale. 20 micron, 10 micron, 5 micron, it all depends on your design considerations. And of course, we discussed earlier, but filter placement, whether it be on the return line, downstream of the filter, or we're talking nominal versus absolute in the system. Here are some common filtration solutions you will see in many applications. The Parker 12AT and 50AT. This is a low-pressure spin-on filter which can be utilized on the suction or return line. The Parker CN, which is a coreless pressure filter. And the Parker WPF, which is an inline or mounted filter. And let me take a quick moment to point out and identify the Parker cross-reference tool that we utilize on Zemarc's website. So with this tool, you can punch in the part number of the original vendor, and the tool will generate a crossover that will be the same in form, fit, and function from Parker. And if you have any questions with utilizing this cross-reference tool, if you reach out to any Zemarc employee, we'd be more than happy to help you with that. Now, apart from permanent filtration solutions for your power unit, there are also some temporary solutions such as the Parker filter cart that can assist your system in removing contaminants. It is perfect for filtering new or contaminated oil that is being introduced into the system, removing contaminants already in the system, and it is most definitely quicker and safer than running your contaminated system to filter internally. Zemarc is a major Parker distributor, and we also offer alternative solutions. Here you'll see a visual for Stoff. We are an authorized distributor for them, and they also offer a great selection of filtration solutions. Thank you for attending today's training, Hydraulics 101 Filtration and Preventative Maintenance. Visit www.hydraulics101.com for more videos and to subscribe for future trainings.
Zemarc,